Hi. To be able to solve this question on matrices, we will need the following notions about matrix multiplication. We have the matrix 4, 3, 3, 2 multiplied to the matrix x negative 9, y negative 10, giving us the matrix 1, 3, 2, 4. To be able to solve for the value of x and y, we need the following notions about matrix multiplication. If we have two matrices, A and B, then the multiplication AB, we know with matrices it is not commutative. AB will never give us the same result as BA. So matrix multiplication is not commutative. Here we will say A pre-multiplies B because A comes first before B. And here we will say B pre-multiplies A because B comes first before A. Here we will say B post-multiply A because B comes after A. And here we'll say A post-multiply B because A comes after B. So we should take note. We're going to need this notion, and we're also going to need the notion that the inverse of a matrix multiplied to that matrix will give us the identity matrix. Since we're dealing with 2 by 2 matrix, is I subscript 2. This 2 here simply means 2 by 2 matrix. So if we get the inverse of a certain matrix and we pre-multiply it, or we post-multiply it, or we post-multiply by the inverse, we're going to have the identity matrix. Then we also need the notion which says that the identity matrix multiplied to any matrix will give us the same result as that matrix pre-multiplying the identity matrix, and the result is the matrix itself. So we're going to need these three notions to be able to solve for the value of x and y. Look at this matrix here. Let us call it A. Let us call that matrix A. Now let's look for the inverse of the metric A. The inverse of the metric A is 1 all over the determinant of A times the adjoint of the matrix A. So the first thing to get is the determinant of the matrix A. The determinant of the matrix A is product of elements in the leading diagonal minus product of elements in the alternate diagonal. So we have 4 multiplied to 2 minus 3 multiplied to 3. This gives us 8 minus 9, which is negative 1. So the determinant of this metric is negative 1. And the adjoint of that matrix is obtained by interchanging the position of elements in the leading diagonal. So this 2 will go up, and this 4 will come down. And then we'll multiply elements of the alternate diagonal by a negative sign or with negative sign. This gives us the adjoint of the matrix A, so that the inverse of that matrix A will be 1 all over negative 1. We're following that formula, the inverse, we're following that formula, multiplied to the adjoint. So 1 divided by negative 1 is negative 1. So we have negative 1. And this gives us negative 2, 3, 3, negative 4. So the inverse of this matrix A is this matrix. Okay, now we've gotten the inverse. We now have to use this second notion. The notion that the inverse pre-multiply a matrix will give us the same result as when the inverse post-multiply that same matrix. We'll get the identity matrix. So, and we also know that the identity matrix multiplied to any matrix will give us the same matrix. So we want to obtain the identity here multiplied to this. Identity multiplied to this will just give us this. How do we get the identity? By pre-multiplying both sides by the inverse of this matrix. If we multiply here by the inverse of this metric and pre-multiply this one by the inverse, remember we are doing equality. What we do to one side, we do to the other side. We'll obtain the identity multiplied to that. So let's go ahead and do pre-multiplication. Okay, so let's pre-multiply both sides. Pre-multiply both sides by A inverse. All right. So let's take the left hand side. We'll have the inverse is -2, 3, 3, -4, multiplied to 4, that matrix, 3, 3, 2, multiplied to x, y, -9, -10. Okay, that is equal to the right hand side. We also pre-multiply. So we obtain the inverse of a matrix multiplied to the matrix. Inverse of a matrix multiplied to the matrix is simply the identity matrix, and the identity 2 by 2 matrix is 1, 0, 0, 1, multiplied to x, -9, y, -10. That should give us this other product. This product here, we have -2 times 1 is -2, 3 times 3, 9. -2 times 2 is -4. 3 times 4, 12. 3 times 1 is 3. 4 times -3, -12. 3 times 2 is 6. 4 times -4 times 4, -16. So we obtain identity matrix multiplied to any matrix will just give us that matrix. So we have x, y, -9, -10 to be equal to this result. The result here is 7. -2 plus 9 is 7. -4 plus 12 is 8. 3 minus 12 is -9. 6 minus 16 is -10. Okay. Now, we have this matrix equal to this matrix. What do we see? Corresponding entries must be equal. This entry here corresponds to this, they are equal. This entry corresponds to this, they are equal. Automatically, this entry which corresponds to this must be equal. So we'll say x equals 7. This entry which corresponds to that must be equal. And so y equals 8. So these are the values of x and y.